Marine biologists have noticed that the color of the outermost growth band on a clam tends to be related to the time of year in which that clam dies. A biologist conducted a small investigation of whether this is true for a certain species of clam. She collects 50 clam shells in February, 43 clam shells in March. 30 of the shells from February had a dark color on the outer band, and 20 of the shells from March had a dark color. We want to do a hypothesis test with alpha of 0.01. So P bar is the weighted average x1 plus x2 over n1 plus n2. Let's calculate that. First of all, what's my n1? N1 is the clams from February, 50. N2 is the clams from March, 43. My x1 will be the successes from February, which was 30. And my x2 is the successes from March, and that's 20. Alright, so those are all the things I gotta plug in. 30 plus 20 over 50 plus 43. We get this weighted average of P bar being 0.538. Okay, then we're going to want Q bar, which is 1 minus P bar. And I'm getting... Okay, then, now that we have that, I can go on to check to make sure that we can use the sampling distribution. I'll just do N1 P bar. So that's going to be 50 times 0.538. Then I'll do N1 times Q bar. I'll do N2 times P bar. And we'll do N2 Q bar. 27. 23. 23. And 20. So all of these are at least 5. So we can use the sampling distribution and assume it's approximately normal. Okay, next. According to the steps, we want to decide what claim is being made. Does the claim include equality and such? Find HO and HA. Alright, now this researcher wants to know, is there a difference between February and March when it comes to the color of these shells? And it says here, see if there is a difference in them. So I'm going to make the claim that the proportion of 1 is not equal to the proportion of 2. That is my claim as the investigator. That is HA because it doesn't include equals. And so HO would be P1 equals P2. Now I have my hypotheses. We'll determine if it's a left, right, or two-tailed test using the significance level alpha and find the negative ZC and ZC. It's a two-tailed test. So we're going to have 2 rejection regions. And we want to use an alpha of 0.01, so let's go to the tables and find the ZCs that go with that. If we look up a two-tailed test where alpha is 0.01, we can go all the way to the bottom of the T table and And this is the z-score that we're looking for. The cutoff will be 2.576. Okay, now another way to look that z up would be to figure that the confidence level would be 1 minus the alpha level. And so confidence level would be 0.99. And so that would be another way to find those cutoffs, because if we go to the table, there's a shortcut table right here for a confidence level of 99%. And it's approximately the same value. They ask us here for the point estimate for the true difference in proportion of dark growth bands in February versus March. So what they're talking about there is they're talking about the first part of the z-star formula for this, which is P1 minus P2 right here. So we just have to find the empirical proportion P1 and the empirical proportion P2 and subtract them, get the difference. That's the point estimate that they're asking about. Okay, we need P bar, Q bar, 1 over N1 plus 1 over N2. Okay, that's going to be our test statistic formula. You may see it written sometimes as z-test, but that is what they're talking about there, z-star. Let's find out what the empirical proportions are for these months. So for February, we'll have P1 hat equals X1 over N1. So we just have to divide the number of successes in February, which was 30, by the total number of clams that were checked in that month, which was 50. That's 0.6. And then March, we have P2 hat equals X2 over N2. And X2 was 20. 43 clams were collected that month. And I get that. So there's definitely a difference in the proportions, and that's what they're talking about when they say find the point estimate. They want to find the difference between these two proportions. So I'll do that on the side here. P1 hat minus P2 hat is going to be 0.6 minus 0.465, which is 0.134883721. So this here is our best estimate of how different the proportions of the clam color bands are. Okay, so 0.1349. So that goes here. Now they want to know the actual value of the test statistic, so we have to carry out the calculation here. Let our hypothesized difference be 0, assuming that the null is true. That's how we do the test, assume that's true. If it was true, P1 would be equal to P2, and when you subtract them, they would cancel to 0. Then over here we'll put P bar. Q bar. 46237. Then we'll do 1 over N1 plus 1 over N2. And we'll see what that gives us. Alright, looks like I'm getting 1.30. So that value would go here. Alright. So am I in the rejection region? Apparently not. We're between 0 and 2.5, so we're right around here with our test statistic. That's going to be Z star. And so now it comes to part C, where we want to find the p-value for that. So to get the p-value, you want the area in the tail that the star here makes. So that would be this area all the way out to the right. It doesn't stop at the ZC boundary. We need that whole tail area there. But with a two-tailed test, one thing that we said before was that it had to be symmetrical, the p-value. That way you can really compare it to alpha, because alpha is both of the yellow tails there. So we need an equal and opposite area on the left. And we have to add those two blue areas together to get the p-value. So what I mean is, you've got your alpha is this area, the yellow area. Okay, that's alpha. It's the combined area. And then the p-value here is going to be shown to be bigger than that. That's how you compare them using p-value. It just shows that your test statistic is closer to the mean, closer to 0, than the cutoff ZC value is. So this is P. And we will show in this test that P is greater than alpha. Okay, so let's find out what p-value actually is. We just have to look up the Z star of the 1.3078. Now, many ways to do it. I'll just go to formula sheets. But instead of looking up the positive of that, I am going to choose to look up the negative of it. Because even though my Z star ended up over here, there would be an equal and opposite Z star over here, which is negative 1.3. So instead of looking up the positive 1.3, I'll look up the negative 1.3, because at least that'll give me the area in the left tail here. And I can certainly use that for my p-value, but I just got to double it. Okay, so I'm going to look up negative 1.3 right here. 0.07. So we want, yeah, this value here, 0.0968, and we'll just double it to get the p-value. So 0.0968, I'm going to do 2 times that. That is going to be the p. I'm getting 0.1936. So on calculator to get the p-value, we would just go to second distribution, and then we'll go to normal CDF because we want to add up the area from one location to another. We could set our lower bound as just negative infinity, which just put in negative 100 or negative 1,000. Then for our upper bound, I'm going to put in negative 1.3078. So that was the Z star I got, but I made it negative because I just want the left tail for now. Alternatively, you could go from, you want positive 1.3078, and we'll go to infinity, which is effectively 100 or 1,000. Okay. So that's a little bit more precise value for the tail. So now we'll just double it. That's going to be our p-value. As you can see, it is a little different from what I had entered. It's 0.1909 on the calculator. What correct decision should we make? We will fail to reject HO. So that's going to be this choice here. It's the only one where we fail to reject HO. And we do not conclude that the proportion of dark colored shells are different in February and March. Yeah, see, we don't reject HO because the P is greater than alpha. P was 0.1936. The alpha level was 0.01. So we're going to definitely say that P is greater than alpha. So we will fail to reject HO, meaning that we like HO and we don't like the claim. So even though the person claimed that there would be a significant statistical difference between these clam color bands, we showed that it wasn't enough of a difference to rise to the 0.01 significance level. It didn't even rise to the 0.05 significance level. So we would say that there is not a statistical difference between February and March.